So hi friends, so we've been discussing about a flow through pipes. So here let's discuss about a sample problem on flow through pipes in series. So we have pipes which are connected in series and parallel. So first we will discuss on pipes which is connected in series. So I have a sample problem. It is taken from a textbook. So three pipes of 400 mm, 200 mm, 300 mm diameter have a length of 400 meter, 200 meter and 300 meters respectively. So they are connected in series to make a compound pipe. So compound pipes are pipes which is like the series of pipes connected makes a compound pipe. The ends of these compound pipes are connected with two tanks whose difference of water level is 16 meter. So the two ends of a pipes which is been connected in a tank. So we have two tanks which has been connected by these pipelines whose difference in water level is 16 meters. So from tank 1 to tank 2, so the height difference is 16 meters. If coefficient of friction for these pipes is same and it is equal to 0.005, so F value, which is coefficient of friction, is given 0.005. Determine the discharge through the compound pipe, neglecting the minor losses, then including them. So first we're going to find the discharge through the pipes by neglecting the all minor losses, then we're going to include all the minor losses and find what will be the discharge. Okay, right. So as we know, the given water level, difference in water level is 16 meter. So length of pipe 1 and diameter is given, so 400 meter and length is 400 meter. So for pipe 2, length is 200 meter, diameter is also 200 meter. So for pipe 3, the length is 300 meter and diameter is also 300 mm. The diameter is already in mm. So we're going to convert in terms of meters. So also it is given that coefficient of friction is same. So it is like F1 equal to F2, which is equal to F3 equal to 0.005. So first we're going to find the discharge through the compound pipe by neglecting the minor losses. So as we know from the continuity equation, A1 V1 equal to A2 V2 equal to A3 V3. Right, so we're going to make V2 V3 in terms of V1 because we don't know either the velocities. Okay, so or the discharge. So V2 will be equal to A1 V1 equal to A2 V2. So V2 will be equal to A1 V1 by A2. So if you substitute the diameters and simplify them, we will get V2 will be equal to 4 V1. So then A1 V1 equal to A3 V3. So V3 will be equal to A1 V1 by A3. So substituting the diameters, we will get V3 will be equal to 1.77 V1. Okay, so using the formulas in terms of Bernoulli's, so here we know head losses will be equal to first we're going to neglect minor losses. So the major losses are frictional losses, which is 4F LV square by 2GT. So this has been derived based on we got based upon derivation on Darcy ways back. Okay, so 4F L1 V1 square by 2GD1 for pipe 1. So this is for pipe 2 and this is for pipe 3. So H, we know that it's a head difference which is 16 meter. So 16 will be equal to, for the first set of frictional values, major loss values. So 4F is also known, so length is also known. V1 we have to find out, so divided by 2G D1. So for D1, 2 into 9.81 is acceleration due to gravity. So again for frictional, major loss in pipe 2, so 4F L, so 200 meter. So V2, instead of V2, we know V2 will be equal to 4V1. Instead of V3, we're going to substitute 1.77 V1. So this we substitute and simplify these terms. So we'll get V1 will be equal to, because we will get all this value in terms of some values of V1. Okay, so that will be equal to 16. So then V1 square will be equal to 16 into 2 into 9.81 by 403.17. So V1 will be equal to square root of 16 into 2 into 9.81 by 403.14. So if we simplify, we will get 0.882 meter per second will be the velocity in pipe 1. So if V1 is known, probably you can able to find V2 and V3. So 4 into V1, 1.77 into V1, so you can find the velocity 2 and velocity 3. So we know discharge will be equal to Q will be equal to A1 into V1. So area is known from the diameter, V1 we have found out. So the discharge will be 0.1108 meter cube per second. So this was based upon neglecting the minor losses. So next case we are going to include the minor losses also. So what are the minor losses? We can see the two tanks are connected, right? So the compound pipes are connected with two tanks. So from first we can know, so from tank, so we'll have an inlet. Okay, so then from inlet, what else we have is certain the pipes of diameter 400 mm, 200 mm and 300 mm. So we have a reduction in diameter. So from inlet we have a head loss due to friction. Throughout there we will be having a friction. Then we have a sudden contraction. So from 400 to 200 mm we have a head loss due to sudden contraction. Then we have a head loss due to friction in pipe 2. Then from pipe 2 we have a sudden expansion. So it is 300 mm. From 200 to 300 there is some expansion. So we'll have head loss due to expansion. Then from pipe 3 we have a head loss due to friction in pipe 3, then to exit at second tank. So we'll have 1, 2, 3 major losses, and inlet, contraction, expansion and exit will be the minor losses, right? So you can able to see here. So first one will be inlet, the second one will be the contraction, the third one will be sudden expansion, the fourth one will be outlet of the pipe, right? So these are minor losses, and the major losses, as we know, will be due to frictional losses. Okay, so already we know that at inlet, so HI will be equal to 0.5 V1 square by 2G, the formula. So HV will be equal to 0.5 V2 square by 2G. We know the V2 value, which is 4 V1 square, or if you have we've been neglecting all this, we will not consider all those into action. So 4 V1 square by 2G. Okay, then sudden expansion, so V2 minus V3, right? So from pipe 1, pipe 2 to pipe 3 it is enlarging, so V2 minus V3. Okay, so whole square. So we know the value of V2 and V3, substitute them, and if you simplify, so you'll get 4.973 by V1 square by 2G. So at pipe outlet at pipe 3, so V3 square by 2G, V3 we know 1.77, V1 square by 2G. So simplify, we will get this value. So major losses we know due to friction, 4 of LV square by 2GT. So substituting all these major losses and minor losses, so we'll able to get 16 will be equal to some values. This was 16 will be equal to this head loss. Head loss will be equal to major losses plus minor losses. So we're simplifying all these major losses and minor losses, so we'll get 419.746 V1 square by 2G is equal to 16. So V1 square will be equal to 16 into 2 into 9.81 by 419.746. So V1 will be equal to square root of these values. So if we simplify, we will get 0.864 meter per second. So if you are known with velocity 1, so discharge will be equal to A1 into V1. So diameter known for pipe 1, so pi by 4 D1 square into V1 will get 0.1085 meter cube per second. So this was the discharge in a pipe considering the minor losses, so it is 0.1085. so this was a discharge which has been neglecting the minor losses, is 0.1108. so there is some slight difference between these values because we have neglected here, so we have considered minor losses, so we will have some more additional loss in discharge. So it's 1085, 0.1108. So simple. Okay, so thank you guys. We have got few glimpse support pipes connected in series. Thank you for watching.